You know, for years, a tiny credit card-sized computer has been quietly powering everything from home projects to complex industrial robots. But with the release of the Raspberry Pi 4, tiny suddenly meant unbelievably powerful. So let's dive into this massive leap forward and see what really makes this little board a true game changer. At its heart, this is what the Raspberry Pi is all about: a complete, totally capable computer packed onto a single, tiny board. I mean, look at it. This simple idea has completely revolutionized what makers, students, and even professional engineers can build, making powerful computing accessible to pretty much everyone. All right, so here's what we're going to cover. We'll start with the Pi's origin story. Then we'll get to the main event, the revolutionary jump to the Pi 4. We're going to break down the hard numbers, explore what you can actually do with all this power, and then we'll help you figure out which Pi is right for your next big idea. Now, believe it or not, the Raspberry Pi didn't start its life as an industrial titan. Its journey began with a really simple, brilliant goal: to create a super low-cost, accessible computer just to get more people into coding and electronics. But its versatility, well, that quickly pushed it way beyond the classroom. So what are we actually talking about here? It's a single-board computer, or an SBC. Just think of all the essential parts of your desktop PC. You know, the processor, the memory, all the plugs and ports. Now imagine them all shrunk down and living on one single board. That efficiency is the secret sauce to its size, cost, and power. Before the Pi 4 showed up, the Raspberry Pi 3B Plus was the undisputed king. It was the last and most polished version of that classic Pi family, a super reliable workhorse that the community absolutely loved. It was great for sure, but everyone kind of knew it had its limits, especially when it came to things like networking speed and memory. And then everything changed. The Raspberry Pi 4 wasn't just another small update. It was a ground-up redesign. It was basically a declaration that these little single-board computers were ready to break out of the hobbyist space and take on some really serious, performance-heavy jobs. Don't just take my word for it. The creators themselves put it perfectly, calling it desktop performance comparable to entry-level PC systems. That phrase right there, desktop performance, that's the key. All of a sudden, this little board wasn't just for blinking some LEDs. It was for running a full desktop, driving 4K displays, you name it. And a quick peek at the core components tells the whole story. We're not just getting a slightly faster CPU here, no way. We're getting a completely different architecture, the Cortex A72, and a jump from a single gig of kind of slow LPDDR2 RAM to options with up to 8 gigs of much, much faster LPDDR4. This was a monumental shift. Okay, let's break this down even more. I mean, just look at this chart. You can see the CPU architecture is way more advanced. The RAM isn't just bigger, it's a whole new, faster generation. We finally get USB 3.0 ports for speedy things like external hard drives. The display output is doubled. 2 micro HDMI ports that can handle 4K. And here's a huge one. Look at the Ethernet. It's now true gigabit, which finally got rid of that old 300 megabit per second bottleneck that made things like a home file server feel so sluggish. It's a massive upgrade across the board. So specs on paper are one thing, right? But how does all this stuff translate to real-world performance? Well, let's get to the benchmarks, because trust me, the numbers don't lie. The performance gains here are just staggering. First up, RAM bandwidth. 110% improvement. This is huge. It means multitasking, like having a bunch of browser tabs open while you're coding, is way smoother, apps load faster, and handling big files is just so much more efficient. This is one of the biggest reasons it has that desktop feel. Next, networking. A 181% speed increase. By moving to a true gigabit port, the Pi 4 is just not held back anymore. This makes it perfect for a network-attached storage device, a media server, or really any project that needs to shuffle a lot of data quickly over a wired connection. And here it is, the power of USB 3.0, a 600% increase in write speed to an external drive. This is what transforms the Pi 4 into a totally viable machine for working with large files, like maybe editing video or running a database straight from a fast SSD. It is an absolute game changer. So here's the crucial question. What does all this new power actually unlock? I mean, these technical specs aren't just for bragging rights. They open the door to a whole new world of advanced projects for professionals, makers, and students. For engineers, the Pi 4 is an IoT powerhouse. It can act as a central hub or gateway for tons of sensors. And with that extra processing power, it can work as an edge computing device. Think of it like giving your sensors a mini brain right on site. It can analyze data locally instead of sending every little thing up to the cloud, which saves bandwidth and gets you answers way faster. And in robotics, the Pi 4's performance allows for so much more intelligence. You can run complex computer vision software like OpenCV right there on the robot itself. This means your creation can make its own autonomous decisions in real time without being physically tethered to a more powerful computer. And of course, the Pi has not forgotten its roots. For students and hobbyists, all this extra power makes the learning experience even better. You can build way more ambitious projects, experiment with more complex circuits, and tap into this massive ecosystem of tutorials and add-on boards, which are known as hats. Now, with all this power, there are a couple of practical things you gotta consider before you jump in. It's not just about raw performance, but also about the resources you'll need to run it. I mean, all of this extra performance has to come at a cost, right? Let's look at one of the most important factors for a lot of projects: power consumption. And yup, here it is. The Pi 4 does draw more power even when it's just sitting there doing nothing. It's gone from about 460 milliamps for the 3B Plus up to 600 for the Pi 4. It's an important thing to keep in mind, especially for any battery-powered projects. But honestly, it's a pretty small price to pay for such a massive performance boost. So, if you're trying to decide between models, what's the final word? Well, it's pretty simple. The general rule when it comes to computers is just to buy the latest one, and that absolutely applies to the Raspberry Pi. Unless you have a very specific need for lower power, the advantages of the Pi 4 make it the obvious choice for almost any new project. Ultimately, the Raspberry Pi 4 really did mark a new era. It evolved from a simple tool for learning into a seriously powerful platform for innovation. So the real question isn't just what can it do, but with this much power being so accessible, what will you build with it?